This is the presentation for nearest neighbor guidance for out-of-distribution detection. OOD detection has classifier-based methods which derive score function based on classifier's output signal, known as the confidence. They utilize class-dependent information of ID data and provide fine-grained detection, but are often overconfident with far OOD samples, which you can see in Figure B. On the other hand, distance-based methods detect based on distance to ID data in the feature space from penultimate layer. These certify low score for far OOD samples, but has limitation with fine-grained detections, as you can see in Figure C. So we suggest our method, which is nearest neighbor guidance, and our method is composed with two components, where the first one is the base confidence and the second one is the guidance. The guidance is composed of three components, which are the similarity, the scaling confidence, and the top gain ensembling. We first define a bank set which is randomly sampled alpha % of the training set and save the features. Here, alpha is one of the hyperparameter which is 1% in our experiments. We get the feature of the test sample and compute the cosine similarity with the bank set, scale with the confidence of the bank set samples, and ensemble with the top k samples, where k is the other hyperparameter which is 10 in our experiment. Finally, the guidance term scales the test confidence of the test sample. Our method is simple and concise to implement in PyTorch, which you can see in the pseudocode. The strength of our method is first that we only use two hyperparameters, alpha and k. We only use pre-trained network without additional training, so there aren't any more complicated fine-tuning required. Additionally, we can equip our method on top of various types of classifier-based methods and various backbones. Finally, we use a small portion of the train set, which doesn't impose a lot of additional computation and memory. However, our limitation is that the performance of our method depends on the performance of the classifier network. In this slide, from scratch indicates that these two networks are trained only on ImageNet 1K, and transfer learning indicates that these two networks are pre-trained with ImageNet 21K and fine-tuned on ImageNet 1K. And we can see the performance gap between the two groups. With RegNet backbone, which is the best performing network, we attain the state-of-the-art performance with ImageNet 1K testing protocol. We also tried testing by changing the ID dataset with natural distribution shift, which is changing with ImageNet 1K version 2, where we are the first to attempt with this type of setting. With RegNet backbone, we also attain the best performance comparing with previous methods. In this slide, we show the results of the ablation study of the components of our method. The main highlight of the results of these experiments are how the four components introduced in the previous slide are composed. First is when we only use similarity as the score, which is the same as one of the previous method, KNN. The second one is ensembling KNN without confidence scaling of bank set and confidence score of test sample. This worsen results and indicate that confidence scaling is necessary. The third experiment includes confidence scaling as well and shows some improvement without the help of confidence score of test sample. Final experiment excludes only confidence scaling of bank set and shows a bit of improvement. However, both results underperform our suggested method, and we can observe the importance of the synergy of all components. In this slide, we can check the compatibility of our method on top of various type of methods and backbones where performances are improved for all cases. As we mentioned earlier, our method compensates far OOD and near OOD comparing with previous methods, where we show in these bar graphs. On top of various classifier-based methods, our method improves performance for not only far OOD samples, but also near OOD samples for two different types of backbones. Thank you very much for watching this presentation.